Hi there, this is Carolyn Pelletier, Senior NLP Engineer at Mantium. Today I'm going to demo 5 different applications that I built within Mantium in the healthcare domain. So today I am going to show you applications that I built using OpenAI's GTP3 model, but I also could have used any of our other providers such as AI21, Cohere, Eleuther AI, and more to come as well. So just to talk about a bit of the motivation behind building these applications, the first one is masking protected health information in clinical notes. So sometimes you'd like to mask the PHI in place in these clinical notes to anonymize sensitive medical information. The next application is, rather than masking the sensitive information in place, I'm extracting this sensitive information, and this is useful when you would like to extract, for example, a condition and send it as an input to a different model that might perform some type of classification, for example. The third application is transforming medical abbreviations into natural language. So, doctors and nurses often take shorthand reports while they see patients, and then they have to sometimes write this out in natural language for insurance purposes, and this application will give it a nice first pass. The fourth application is synthetic clinical note generation. So these synthetic clinical notes can be conditioned on a variety of different inputs, such as medical abbreviations, PHI entities. And so what this means is that this application will actually take a more creative approach to synthetically creating clinical notes, and it will do so with a variety of different types of inputs that it will use as its starting point. The fifth application uses what we call within Mantium an intelet, and we're going to go ahead and connect applications 2 and applications 4 together. And so what we're going to do is that we're going to give it an input. It's going to extract the PHI from the clinical notes and send this to our fourth application, which will then use these extracted PHI to generate synthetic clinical notes. And this is very powerful because pretend, for example, you have an input like this. You'd like to only extract the age and the condition of this patient, but you'd like to leave out, the patient's address. So what you can do is extract the age and the patient's diagnosis and leave out the address. And then so when you're synthetically creating this note, it will not include the person's home address in it, but it will include the features that you would like for it to synthetically create notes for. So this is a very powerful way of connecting 2 applications together. All right, so let's get into the demo. So like I said, I built all of my prompts within Mantium's AI Manager, and so I configured them in our AI Manager, and right now I'll show you how I am deploying them with one click to be able to demo this application. Great. So now I have my application all set up for me very easily. I can share this with others within my own company or with whoever I'm demoing with. And so this use case here is about masking the protected health information in clinical notes. And now I'm going to go ahead and just grab my input rather than typing it out. And let's take a look at the output of this endpoint. Great. So you can see here that the PHIs were masked in place. So the age and the condition was masked in place. The next application is, rather than masking the PHI, we are going to extract the PHI. And the goal, again, is to be able to pass this on to a different model potentially. Great. So here we have the age, 45, and the condition, high blood pressure. The third application is about transforming medical abbreviations into natural language. So here we have some medical abbreviations that are often taken from doctors or nurses that are quickly taking notes about the patient. And these medical abbreviations oftentimes need to be transformed into natural language. Great, so we have patient is a 18-year-old female with the chief complaint of headache. She has a history of migraines. And now let's look at our fourth application, which is synthetically creating clinical notes, so synthetic clinical note generation. And this one, we've tweaked the parameters of this model to allow it to take a bit more of a creative approach to this synthetic note generation. And we've also allowed it to output a lot more text. So we've increased the max tokens parameter. So here we have patient is a known IV drug user. Patient is a 26-year-old female who is a known IV drug user. She was admitted for an overdose. So it takes a bit more of a creative approach to the input that we gave it, the input that we gave to the model. And now let's look at our last application. Again, this is connecting application 2, so extracting PHI, to this synthetic clinical note generation. And we do this through what we call an intelet. Great. So you see here that we've extracted the conditions or the entities that we want. So we train the model to only extract age, health condition, and a variety of other entities. And we, in this case, excluded PHI's like address, so that you see that when the generation of these synthetic clinical notes are being made, it does not include the address of the patient. So we have a 45-year-old woman with a history of hypertension, diabetes, meticulous present, and it talks about the high blood pressure, but it does not include the address. We can also execute it again and see what other creative approach it takes. So here we have a 45-year-old male with a history of hypertension, and again, it excludes the patient's address, but includes the conditions that we want. So you might have noticed in the previous example that our input was talking or discussing about a male, and the output actually generated synthetic clinical notes about a woman. And the reason for this is because this intelet is made up of an AI, so it's made up of two AIs. So the first one, just to remember, is extract PHI and clinical notes. And then it's also made up of this one, synthetic clinical note generation. And this synthetic clinical note generation, as I mentioned before, we've allowed it to take a more creative approach. And we do this by increasing the temperature of OpenAI GPT-3's model. And so what this does is that it doesn't always follow the input that we give it. And in our use case, that was okay. But in this particular use case, for example, transforming medical abbreviations into natural language, this one, we wanted it to follow, wanted to have more of a factual approach to the output. And so for this use case, the temperature is set right to 0. So it's all the way down to 0. And that's how we were able to get the model to do what we want. And so you see here that the second AI that's involved in this intelet definitely takes a more creative approach. And what's great is that you can continuously execute this AI and get several different outputs for this synthetic clinical note generation. And all of these outputs are saved in Mantium in the log feature. And whoever I share this application with, I'll also be able to log and see the outputs of this application. And this is incredibly powerful because I can see the inputs of other people, I can see the output of the model, I can do a lot of fine-tuning, and I can also use these outputs to build a data set to then fine-tune a model in the way that I want. So I'll keep the outputs that look great, I'll exclude the outputs that don't look so good, and for the outputs that look great, I can fine-tune a model and adapt it to exactly what I need as a business user. And to quickly show you where the logs look like, here we go, it's in monitoring, and I look at the logs, and so here we see all the logs that we were hitting. I'm able to see everything in this very nice view.